Energetics. The definition of enthalpy change, delta H, the heat energy transferred in a reaction at constant pressure. Heat energy transferred in a reaction at constant pressure, the units of delta H is kilojoules per mole to power minus 1. Definition of this, when it's like delta H and that, substances were in standard states and the measurement was made under standard conditions, 100 kilopascals of pressure, 298 Kelvin, bracket 25 degrees Celsius. Delta R, H, enthalpy change of a reaction, that's what it means. Exothermic reactions give out energy, delta H is negative. State 2 examples of exothermic reactions. Oxidation reactions, so the combustion of a fuel like methane, CH4 gases plus 2O2 gases to form CO2 gases plus 2H2O liquid. Oxidation of carbohydrates, bracket glucose in respiration, oxidation of glucose in respiration, and combustion of a fuel like methane. Endothermic reactions absorb energy, delta H is positive. Say 2 examples of endothermic direction of endothermic reactions. Thermal decomposition of calcium carbonate, CaCO3 solid, ROCAO solid plus CO2 gases. The main reactions of photosynthesis is also an example of endothermic reaction, as sunlight provides energy, supplies the energy. Definition of specific heat capacity of water, amount of heat energy it takes to raise the temperature of 1 gram of water by 1 Kelvin. Why is bond breaking endothermic? We need energy to break bonds. Stronger bonds take more energy to break, therefore bond breaking is endothermic. Why is bond making shouldn't say endothermic. Why is bond breaking? Let me just double check one thing. Bond breaking is endothermic. Bond making is exothermic. Yeah, so why is bond breaking endothermic? We'll need energy to break bonds, therefore stronger bonds take more energy to break. Why is bond making exothermic? Energy release when bonds are formed. Stronger bonds release more energy when they're formed. Energy release when bonds are formed, therefore bond making is exothermic. Bond enthalpy, energy required to break bonds. Mean bond enthalpy, average energy needed to break a certain type of bond over a range of compounds. Average energy needed to break a certain type of bond over a range of compounds. State why the bond enthalpy for OH is, the data book value is different. Whereas the average for a bigger range of molecules is not just water, the OH could be for carboxylic acid, etc. Enthalpy change of reaction equals the total energy absorbed minus its total energy release. State key factor about enthalpy changes calculated using mean bond enthalpies. Mean bond enthalpies use average values, therefore aren't exact, so less accurate. Define standard enthalpy of formation, delta FH, and that means substances were in the standard states and measurements were made under standard conditions. Enthalpy change, 1 mole of compounds formed from its elements under standard states, under standard conditions. Standard enthalpy of combustion, delta CH. Enthalpy change, 1 mole of a substance is completely burned in oxygen under standard conditions. Standard enthalpy of formation, enthalpy change, 1 mole of compound is formed from its element in standard states under standard conditions. Standard enthalpy of combustion, enthalpy change, 1 mole of compound, 1 mole of a substance is completely burned in oxygen in standard states. 1 more mole of a substance is completely burned in oxygen under standard conditions. Why mean bond enthalpy is always positive? Breaking bonds is endothermic. Therefore, mean bond enthalpy is always going to be positive because mean bond enthalpy is breaking bonds. Therefore, it's going to be endothermic. Delta is positive. Say key factor about every time you break a bond. Energy needed to break a bond depends on the environment it is in. I mean bond enthalpy, average energy needed to break a certain type of bond over a range of compounds. What is the enthalpy change of reaction? Overall effect of 2 changes. If we need more energy to break bonds than released when bonds are made, delta H is positive. If it's less, delta H is negative. Definition of Hess's law, the total enthalpy change of a reaction is independent of the route taken. The total enthalpy change of a reaction is independent of the route taken. And that's it for energetics. All the practicals in energetics, calorimetry, and all of those will be in the practicals playlist, not in this playlist.